Hi, this is a tutorial video on the interpretation of an item response theory analysis using the software program Xcalibre 4. There will be two examples that we will cover here, one limited to dichotomous IRT and one on a mixed model of IRT, that is, some items are dichotomous and some of them are polytomous. So first you see here we have a dichotomous example item parameter calibration report. So Xcalibre produces, in addition to spreadsheet-based output, it also gives you a Microsoft Word style output like you see here. So it begins with the title page, some of which is changeable by running the program, some of which you can just change right here on this page if you like to work with whatever you are working with. On the first page of the output, we provide a summary of what the specifications of the program were. That is, what were the input files that you used, and what were all of the program specifications that you used when you ran the program. So it starts by giving you a summary of the data that you used. In this case, you can see we had 50 examinees and 40 items, of which there were 30 calibrated items, 6 were pretest, and 4 were excluded. These items were divided into 3 domains. And the rest of this involves formatting of the input files and the types of output that you wanted to use, such as whether you wanted to produce the fit line on the graphs, whether you wanted to plot the IRFs, how many groups you wanted to use for the plotting, and so on. The next table provides the IRT calibration specifications. Like the table before, these are not provided so much to be interpretable output, but provided for you for historical purposes. That is, if you were to come back and look at this report a year from now, you'd be able to remember what you did. This is especially true if you run a certain report maybe once a year or once every 6 months. You can be sure that you run it under the same specifications because you can come back and check what specifications you used. The next section of the output provides results of the EM algorithm. That is, Xcalibre uses a loop-based expectation maximization approach using marginal maximum likelihood to calibrate the item parameters. And this is an iterative process and goes through each of the loops until the accuracy specification is met or until you meet a certain maximum number of loops. So you can see this analysis here was set to reach a maximum of 20 loops, and after hitting loop 20, it stopped and produced the rest of the analysis. One important thing to note here is that item 7 is mentioned each time in this list here. That means that for each one of these loops, item 7 had the largest change in its item parameters, which means that item 7 is most likely the problem item that you should look at. The report then gets into actual output regarding the item response theory analysis. You can see in table 4 it provides summary statistics for all the calibrated items, and in this case there were 30 calibrated items, which had a mean A parameter of 0.656, a mean B parameter of minus 1.695, which is pretty easy, and a mean C parameter of 0.258, which is not surprising because this is 4-option multiple choice data. It then provides the same statistics for domain 1, domain 2, and domain 3. If you recall, this test had 3 domains. And then it provides some classical based statistics for the total score as well as each of these domains, such as the alpha reliability and the mean raw scores. Provides some summary statistics for the same pieces in terms of IRT theta estimates. And for scaled scores, you can see that we converted the theta estimates into having a scaled score of mean of 50 and a standard deviation of 10. And then lastly, we provide overall model fit based upon a chi-square and minus 2 times the log likelihood. This is especially useful for comparing models. So example, you could run Xcalibre under the 3-parameter model and run it again under the 2-parameter model and compare the chi-square and negative 2 log likelihood. The output then provides a record of all of the item control file that was used for these items, so that if you were to come back to this much later, you could see which items were included, which items were only pretest, which were removed, how many options you specified, and what was the key, because you might have changed the key on items at a later point. It then provides a summary of the item parameters, just so you can see in an overall picture of the item IRT analysis. You can see we had 38 items in here. There were 30 items. You can see there are 30 items in here. Go up to number 38 because some were removed. We have the p-value for each, the r point by serial for each, and then the a, b, and c parameters. You can see that we calibrated these with a 3-parameter logistic model. The flag here will have flags for possible statistical issues. In this case, there were 4 items that have a k flag for a possible key issue. In this case, it is because these items had an incorrect answer with a higher point by serial than the correct answer does, which suggests that perhaps it was miskeyed because students of higher competency were choosing that incorrect answer. We then provide a number of grouped frequency distributions for all calibrated items, the theta estimates for each domain, then the a parameters and the b parameters and the c parameters. It then gives a b parameter by a parameter graph, so you can see a bivariate plot of the two. Usually what you might find is that items which have a higher b parameter, that is, they're more difficult, will often have a higher a parameter, being more discriminating. But in this case, it was a very easy test in that all the items had b parameters below 0. We also then provide an item person map. The black line is the distribution of the examinee thetas. It's very jagged because there's only 50 people. And the blue line is the distribution of the examinee b's. So you can see, once again, this is a very easy test. We then provide the test response function, which it shows you as function of theta the likely proportion correct for each examinee, as well as the likely number correct out of 30 for each examinee. So someone who is a theta plus 3 will likely get 30 correct, which of course translates to being a proportion of 1.0 or 100%. Whereas someone at minus 1 here will probably get only 24 correct, which is about 0.8. We then provide test response function for domain 1, domain 2, and domain 3, and the test information functions for these also. A test information function is telling you where the test is providing the most information about examinees. And because this is a relatively easy test, the peak of the information is substantially below 0. And as you can see here, the test information function is inversely related to the CSEM, or conditional standard error of measurement function, so that the conditional standard error of measurement is lowest where there is most information. So then we provide the TIF and CSEM curves for each of the domains. And that ends the overall test level statistics part of the report. The report then gets into item by item results. So each item will then have its own page of dedicated results, as you see here. This is everything that you see right now is for item 1 on this test. There's 4 tables. One provides summary item information, which is mostly what was input into the test. Then we have the classical statistics. So this item was seen by 50 people, had a p of 0.92, had a SRP-BIS of 0.033. SRP-BIS means the point by serial correlated with raw score, whereas the TRP-BIS is the point by serial where you're correlating with theta. If we're using IRT here, theta tends to provide finer discriminations of examinee ability, so the theta RP-BIS will generally represent the truer level of discrimination. Let me provide the alpha of the test without this item, that is, if the item was removed. Then we have the IRT parameters for the item. You can see there's an A, B, and C parameter. The standard errors for estimating A, B, and C. Chi-square for the item fit, degrees of freedom for the chi-square, and the p-value for using the chi-square test of item fit. Then we also convert the chi-square into the z residual, or standardized residual, and a p-value for the standardized residual of the fit. And then lastly, we provide the option statistics. So you can see this item had 4 options. 46 of the 50 examinees chose option A, 3 chose B, 0 chose C, and 1 chose D. And because 46 chose the correct answer A, that gives us a proportion of 0.92. And of course, there's the SRP-BIS and TRP-BIS. Typically, what you want to see is that the RP-BIS for the correct answer are positive and negative for the incorrect answers. Then we also provide the mean theta of the students that chose each answer and the standard deviation of theta of the students that chose each answer. Then up above, we provide a graph of the IRT parameters, that is the item response function using these three item parameters. And you can see that the B parameter is at minus 2.291. That means that the graph center, that is where its inflection point, is right here at about minus 2.291. The red line represents the proportion correct, the observed proportion correct of equally divided subgroups. So that is, we divided the sample into 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of examinees and calculated the proportion in each. And typically you want to see the red line closely approximate the black line. And in this case we're dealing with a sample data set of only 50 people, so it's not very accurate. But if you're using a sample of, let's say, 12,000 students, the red line would be much closer to the black line. You can see the results here for item 2. Again, it was a jagged line and a fairly easy item with a B of minus 2.17. Item 3 was more difficult with the B now of minus 1.079 and still a fairly jagged red line. Item 4 was again similar results. Item 5 was removed. Item 6 had similar results. And item 7 also. Item 7 you can see was a fairly good fit in that the red line is more closely approximating the black line. So this is an example of dichotomous output. Let us move to polynomous output. So this example file has mixed IRT example, so that there are some items that are dichotomous and some are polynomous. Now you can see this example had 1,000 examinees, so we have better results and has 70 calibrated items. This one again was set to have a maximum of 20 loops, and it was stopped after loop number 20. Item 60 was the item that was having a problem for the final 4 loops. You can see we provide summary statistics again, but for this test there were no domains, so we're only providing it for the full test. And we're only providing the A parameter because the two different types of models, that is the polynomous model and the dichotomous model, do not utilize the B and C parameters in the same way. We then provide the item control file. And you can see here, in terms of these names, these are dichotomous, so that the first 50 items are dichotomous, and then the final 20 items are polynomous. And then, of course, here's the same table of item parameters for all calibrated items, with the mean, which is a p-value for the dichotomous items, but slightly different for the polynomous items, the point by serial, and the A, B, and C parameters. So this test, we did not use the C parameter. We only used the 2-parameter logistic model for the dichotomous items. And then the polynomous items, you can see there were 5 option items, which means that there are 4 boundaries between the 5 options. So each item will have 4 different B parameters representing those 4 boundaries. And then provide similar output for the frequency distributions, the TIF, and the CSEM. You can see here this item was dichotomous only, that is, it was not a dichotomized multiple choice item, and that is there were only 2 responses here, 0, 1. You might think of this item as an agree or disagree item, so that this test was 70 items. The first 50 were simply agree or disagree, and the last 20 were on a 5-point Likert type scale, such as strongly disagree to strongly agree. So we've already talked about these dichotomous items. You can see these graphs now not only produce the item response function going up, but also produce the 1 minus item response function going down. But let us move to the polynomous items. It's here, item number 52 is a polynomous item. So there were 5 options, so we now have 5 curves in the item response function, also called category response functions, because the options are typically referred to as categories. So this item we had 52 respond in category 1, 160 in 2, 383 in 3, 265 in 4, and 140 in category 5. And these numbers translate to these proportions that you see here. And you can see that the means go up because candidates or examinees that are lower in the trait are going to respond to 1 more often than they'll respond to 5, whereas examinees that are high in the trait are typically going to strongly agree or agree to whatever statement this is. And you can see these reflected in the curves up above. So the maroon is the curve for the 1. And that means examinees that are a theta of -2 or below are most likely going to respond with 1, let's say strongly disagree to this statement. Whereas examinees that are at 1.5 or above are relatively high in the trait are going to strongly agree with the statement rather than disagree with it. And the blue curve is neutral, it's in the middle, and the green curve can be considered disagree as opposed to strongly disagree for the maroon, and the red curve can be conceived as agree as opposed to strongly agree for the black. So this item here had an A parameter of 1.017, which is fairly strongly discriminating. But the next item, item number 53, you can see was extremely discriminating because each of the curves are extremely peaked now. We're quite certain if somebody responds with agree that they're in this red curve, which means they're most likely going to be between -0.5 and plus 1.5 or so. The A parameter for this item was 2.606, which is quite strong in terms of discrimination parameters. We'll then move to item 54. You can see it's similar to item number 52 that we looked at already. And item number 55 is similar too, except this one you can kind of consider to be a more difficult item because all of the curves have slid up to the right. So that now pretty much anyone below -1 is choosing strongly disagree, whereas those previous items, if you go back, you see pretty much anyone below -2 was choosing strongly disagree. And now the only people most likely choosing strongly agree, the black line, are at theta of 2.5 and above, which of course is very, very small portion of the population, just 0.5% at the top. So that is a brief summary of the output produced by Xcalibre 4 for an item response theory analysis. If you'd like to learn more about how to run the program Xcalibre 4, that is provided in a different tutorial video. A separate tutorial is also provided on an introduction to item response theory for those researchers who are new to the topic. If you'd like to purchase Xcalibre 4 or download a free trial version to begin learning item response theory, it is available at www.assess.com. That is ASSESS.com. Thank you.